So we have two different, we're going back to inequalities. We did quadratic inequalities. Remember our two, we had graphing where we said, all right, that part's above the x-axis or below the x-axis. What was the other technique that we had for looking at quadratic inequalities? Two words. No? Starts with an I. That's it. Interval testing or graphing. That was still this same chapter. So we will now put the quadratics in with the polynomials. So you got interval testing, you got graphs. Algebraically is also known as interval testing. Good job, Josie. All right, who else remember that? Oh, Amelia. Okay, give yourself credit. Okay, so graphically, we would probably, okay, let me ask you a random question. When you're texting, do you do this or probably? No. Good. Okay. Prob is good. Okay. Probably we'll have a calculator, but if it's a quadratic, you won't, because the quadratics are just too easy to graph quickly when you have zeros, okay? But for polynomials, if you're going to solve them graphically, you are going to probably have a calculator. Okay, so first step is you want that zero on the right side. Okay, let's think about this. If we're looking for an inequality, isn't it easier to find what's less than zero because we're either on top or below the x-axis, right? Okay, but less than 2, that would just be weird. So that's why we want the 0. Okay, using a calculator graph, duh. Okay, find the x-intercepts and the vertical asymptotes. Remember, x-intercepts and zeros are the same thing. The vertical asymptotes are totally not the same thing. And that's the difference between what Megan was talking about earlier. Okay? Now, what happens is this is the domain issue. Okay? If we take out we figure out the intercepts and we have the domain figured out. Okay? When we have 0. So that's the domain. Then whatever's above the x-axis is where the function is positive. Where it's below the x-axis, it's negative. Okay, so I've taken the liberty to graph some functions for you. Right there they are. Okay, let's figure out. Now, if you just pull up the graph, sometimes it's very difficult to see what the zeros are. And you don't want to take a whole lot of time if you just need to figure out the zero. So if it's on a factor, it'd be very easy to give yourself zeros. What are my zeros? Starting with this one back here. What's the furthest one on the left? 0, furthest on the left. -2, so let's put that right here. Okay? Those are the numbers that make the zeros in the equation. What's the next one I get to? 1. That's right here. I'm identifying those because what I'm doing is I'm getting a graph going here for my interval testing if I want to do that. Okay? And then my last one is 3. Good job. Okay. Now, I am looking. I still have to know some sense about, okay, what is that doing? Is it over here at this end? I know it's, if you look at the horizontal asymptote, what is it hugging? Is it hugging 1 or is it hugging 0? What's the degree on the top? 3. What's the degree on the bottom? 3. We got a 2 here and a 1. That's 3. So now you're taking the ratio of leading coefficients, which is x times x times x is 1x cubed, and x times x times x is still 1x cubed. So,
isn't it
that's what we said.
Oh, I think
Yeah.
I was thinking it's 3 over 6.
No. Degrees 3 over 3. So that's why we're doing horizontal asymptote. Just so there's a lot of details that you have to kind of think about. So it goes over this x-axis and then it hugs 1. But see, depending on your window, that may not be clear. So you really have to be aware. Okay, so we want to know where r of x is less than 0. Okay, when we do this quadratic, we highlighted. So I want to, what do I want to highlighted below or above the x-axis for less than 0? Below. So crosses here, so this is below. And we got this mess here, and then that looks like it probably stays up there. Okay. It's very small, and maybe you'd spend some time doing a window, but this is the graph you got, so we're going to deal with it. All right, so is there any vertical asymptotes that we need to be aware of? 0. Okay, so that's another kind of split there. And 4. Okay, so we really are splitting -2, 0, 1, 3, and 4. We really have all those splits, don't we? Lots going on in that one. But that's, you know. Okay, so tell me what, now this is less than and not less than or equal to. So which, we've got it kind of highlighted, it's kind of a mess. So let's just say this is over the top. Then we go underneath. I'm talking this, let me skip over 0, we're over top. Doing pluses and positive, negative is in negative. That's really dumb that I just said that. Okay, 1 to 3, that's up top. And 3 to 4 is also on top, right? Okay. 1 to 3 is where? Oh, yes, it is. Okay, thank you. Okay. So, when you're looking, I could tell you I made that mistake on purpose, but I didn't. But you are really have to focus on where your things are split. Your equation splits at, remember this is your domain. You can't include 0 and 4 because that's not part of the domain because of the whole vertical asymptotes. And then it also splits here. That's when it crosses or touches. Okay, in this case it just crosses because we don't have any double multiplicities. Okay, so what part of the function is less than 0, Ellie? Interval notation.
Is it
I don't know. Ask you first. Okay, are we including the endpoints? Okay, so it's open parentheses. Okay.
open parentheses, -2, comma 0, parentheses, u, parentheses, 1, comma 3, close parentheses.
Okay, nice. Good job. Okay. Now, let's do where r of x is greater than or equal to 0. Now, this time, we got to include, but don't include the vertical asymptotes or that you can include 0, so be very careful. What, Julie?
When you're writing it, do you write like where the infinities are? Like, do you include that part?
Well, that's at the end, yes. We didn't go there, but it would be a plus, right? This end is your infinity end.
So you write the
Yes,
infinities.
yes. We're going to cover the whole graph. Okay, so r of x is greater than or equal to 0. Where are we, Marcella? This part is, I'll start you off. Negative infinity to, wait, you want to skip over this guy?
Oh, no.
And are we going to include -2? Why not?
Yeah.
Actually, yes, it is a 0, so that should be filled in. Okay? All right. Give me another one, Emma Bowman. because that's a vertical asymptote. Good job. Okay, because that's a 0. Vertical asymptote, you can't include the 0, you need to. Okay, good work. And Ollie, what about anything more?
Okay, so I have a question.
Yes.
3 and 4 are both constant, so you need to differentiate like the pair.
So you're asking me if we just want to do this?
Yeah.
Okay, so that will include 4. Do you want to include 4?
No.
Okay, so then that will not work.
No.
Okay. So the next one is
So it would be like
3.
yeah, that one, 2, 4, with the soft bracket.
Soft bracket. That's a good one. That's a parenthesis. And then 4 to infinity. Okay? I got it. I got it. Yes, Madeline.
Why does it
1 and -2 and 3 are zeros. See this little guy? This equals 0. So we want to include that. But 0 and 4 are asymptotes, so we don't want to include those. Okay? Yes, sir. Okay, remember we're talking about, where's that graph? All this now is going to just hang around at y equals 1, no?
Oh.
It's not going to go back down. Right? Okay. All right. So, there you have g of x. Now, I did not factor g of x for you. Okay? So, let's do it. I'm going to put this on a single page. All right. Okay, so we're doing this one. All right, how does that top factor? How does that? Go for it. All right, go for it. So close. Minus x. These have to be different in order for all those middle terms, Olivia, to cancel each other out. Okay? All right. And what about the bottom? How do you factor the bottom? And we got x plus 2. Okay. All right, so we got a vertical asymptote at 1, 2. I just like to kind of fill in the graph a little bit. You've got also one at 0. You've got a whole where? At -1. That's it, right? I'm not sorry, Cole. I meant Exeter stuff. Thank you. Thank you. Okay. Is there any holes?
No.
No. Where do the holes come from? Canceled values. That's right. Yeah. Okay. There aren't any of those. All right. So what's the first thing we're looking for? G of x is greater than 0, above the x-axis. All right, Harper.
Okay, so. Would you tell me what's about?
Yes, please.
Okay, so you start at -2, not included.
Okay.
This is -2, -1, and don't include that again.
Because we don't have it equal. So she's talking about this part right here. Okay, perfect. So far.
And then, parentheses 0 to infinity.
So then she's talking about this guy right here. Okay. So a 0 is a vertical asymptote. We don't want to include anything here, so we don't really even have to go there. But what kind of a horizontal asymptote is going to be here at g of x? Isn't one, right? It's going to be a kind of a oblique one. Okay. All right. Very good, Harper. Any discussion on that? Questions? Okay, now we're looking at g of x is less than or equal to. Let me pull it up here. All right, less than or equal to. That's below, and now we want to include what we can include. All right, Madeline. So I want to include this piece and this guy. That's it. Negative infinity to -2 and this piece. Before we get to 0, we got something right here. -1, are we including -1? Is it a 0? And we got the less than or equal to, so we need to include it. And we go to what? And we want to include 0? The vertical asymptote. Do we want to include a vertical asymptote? No. So -1, comma 0, parentheses. Okay, that's it. Okay? All right, now we're back to a polynomial. Okay? You would probably need to make sure you know your because I didn't have it factored. So we got to figure out factors. All right, so throw this in your calculator. And do the, if you think you know them, put it in rather than do the left-right business, because it's a whole lot quicker. If they look like they were -3, plug in -3 by using a value. All right, so x third plus 2x squared. Whoops. X minus 5x minus 6. Here and here. Okay. All right. So that's what it looks like. So I believe negative. So if I go -3 and I get a 0, then okay. So that's 1. It also looks like -1 might be 1. So I'm going to hit a -1 again. Okay, so now that other one, you think it's a 2?
Yeah.
Is it? All right. Okay, well, there we go. Okay. If you think you know, I'm just plug them in, and then we're good. All right. Okay, so y is greater than 0. Where would that be, Deidre? Right, where is y greater than 0, and why is this lovely cubic here? Did you say close parentheses?
No.
Okay. Okay. So she's talking about this guy. Okay. She's talking about this. Okay, nothing's included because, first of all, it's a polynomial, and it's not less than. Good job. Okay? And I have another one down there, I'm thinking less than or equal to 0. All right, what does that look like, Megan?
So you have close, or wait, no, you have open parentheses, negative infinity, comma, and then you have close parentheses, -3.
Wait, sorry, negative infinity to what?
-3.
-3, okay. And then you did a bracket?
Yes.
Okay.
And then after that, you do another bracket from 2, wait, no, I'm sorry, from -1, and then another bracket to 2.
So 2 and then the bracket, you mean? So we're talking about this and then this. Sounds good. Okay? Now the vertical asymptotes don't exist on polynomials. Remember, those are fraction functions, so you don't have to worry about those. So this one, except for the infinities, you don't have to, you know, if it's included everywhere. Okay? Any questions? Yes.
Are rational functions a type?
Well, they have a polynomial on top and polynomial on the bottom, but no, they are not.
Okay.
They're composed of polynomials, but they're not a polynomial function. Okay, any other questions? All right. Let's, so algebraically, basically, we're going to do the same thing, except we're not going to have this guy, okay? Be sure the left side is written as a single quotient. This is important, okay? The domain is going to give you the vertical asymptotes and the zeros, okay? Use these numbers to separate the number line into intervals and select the number and evaluate that. Okay, so let's try one here. All right, we got a polynomial. All right. What are my zeros? Whoops, I'm getting ahead of myself. Zeros and or vertical asymptotes. All right, vertical asymptotes. What are those, Julia? Right, thank you for being confused, because there is not any. Right. Okay, how about my zeros, Alyssa? Sure. That might be helpful. All right, -3. Okay, so this guy has a multiplicity of 2, which is even, so it's going to what? Even. Our choices are touch or cross. Cross goes with odd. Okay, this is touching, and this is crossing. Okay. All right. Okay, now we are going to interval test. How many intervals do I have to test? You got 1, 2, 3, 4. But she was thinking she wasn't going to test. She wasn't going to test one because of the multiplicity. I got you. All right. Yes. I am a mind reader. I am a mind reader. All right. Okay, so check out on the left of -3. Now, all you're doing is sign. Don't go crazy. Don't go crazy doing the number. So, for example, -4 plus 3 is that. First of all, are we really going to test that guy? No, because whatever we put in here, when we square, it's going to be positive. Okay, so we're really going to test these two. So -4 minus 1 is positive or negative? Negative. What is -4 minus 4? Negative. And a negative times a negative is a positive. Okay, now, are we touching or crossing at -3 again? So, tell me what that is going to be. Right, because we're just going to dip down and touch and go back. Well, we're just checking. I'm not doing the work, but you're just saying, here's your, if you need the table, you're doing this. These are your intervals. This, and one more. All right. Now, you can be smart about this or you can be methodical. Not always the same, okay? Sometimes we forget to think we're just being methodical, but okay, if I'm crossing at 1, that means I went into plus territory and crossed, and now I'm in. Okay, now I can check it out. If I check out a 2, again, I'm not going to check there because I'm wasting my time. That's always going to be plus because I'm squaring. 2 minus 1 is positive. 2 minus 4 is negative. A positive times a negative is a negative. Again, I'm in negative territory. I'm going to cross again, so this is going to be, okay. So you don't have to show me this big old thing here. Okay? If you need to, do it. I don't care. Yes.
If the x plus 3 is not squared, would you have to put it into all 3?
Yes. Yes, you would. Okay, so we want less than or equal to 0. What is that? Below or above the x-axis? Below, as in what kind of a number? Positive or negative?
Negative.
Okay, so we want the negatives. So that means what are your answers, Nicole? 1 and 4. Are we including 1 and 4? Yes. And why are we including those? Because of this guy right here. Okay? All right. Okay, so that's a polynomial. It's very similar to a quadratic. It's just a little bit longer. But use your multiplicities. Thank you, Alyssa, for bringing that up. I think it was you, wasn't it? Yeah. Yes. That's excellent planning. It saves you a little time. Remember, we all have not enough time in our days, right? Right. Anything we need to see again, anyone? This is your answer. All right. Let's try this guy. Okay? All right, now, just to make sure we follow the rules here, we want a 0. Okay? On the right. Just because we either want to be greater than 0 or less than 0. Okay, so what does that look like, Elena, with the 0 on the right? What's over here on the left? X minus 4 over x plus 2 minus 2 is, very good. Okay. All right. Now, this is ugly. Remember, we want to write that as a single quotient. So, you want to write this as a single quotient with a numerator and a denominator. Why? Those are rational functions, and we know we got vertical asymptotes, we got all that business. But that, otherwise we don't. Yes, Megan. Got it? Go for it.
So instead of just subtracting the negative 2, like instead of taking the 2 from one side and turning it to the other, divide both sides by 2, which is multiplying it times 1/2. And
Wait, what?
Yeah, it's what
It doesn't give you 0, it gives you 1.
Oh, you're right. I'm sorry.
Okay. All right.
Yeah.
Now, 1 is not what we want. We want 0. All right. She wants to divide here by 2.
Maybe I'm hearing this.
You are.
I think you're dating someone. That's a good thing to say. I'm like,
I heard that for a second.
okay.
All right. So my single denominator is going to be x plus 2. Right? His current denominator is 1. I need to make it x plus 2, so I need to make x minus 4 minus, what is that now? I'm going to make a mistake, just on purpose. Okay, what's the mistake? Minus 4, because I have to take the minus 2 times x plus 2. All right, that's a very common mistake. That needs to be minus. Okay? All right. Now, some of you will do, because you're just good. Hello, what's happening? Wow. Sorry, let me go back here. Let me. Okay, some people will do this. okay? In between there. You gotta do it, do it. Whatever you gotta do, you're in charge. Okay, now what?
Combine my terms.
Yeah, that's a good idea, Olivia. What is my combining like term look like?
You just, wait. Oh, sorry, I wrote 2 instead of 4. 8, sorry.
Okay. You forgot to distribute?
No, I distributed. I didn't write it.
Okay, now, determine the real numbers. You want the zeros and you want the VAs, because remember that's a domain here. So my domain is everything but, I'm not going to go crazy, -2. I can't be -2, so -2 is a split where I'm going to have an interval, end or beginning, whatever way you're looking at it. What's the other split? -8. So there. -x minus 8 equals 0. -x equals 8. X equals -8. Okay? All right. Now, so that's how we find, that's why we want the single, everybody listen, that's why we want the single quotient, because that is now a rational function that you know how to graph, blah, 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 you know all that. Okay, so.
Wait, so -8 is your 0, but -2 is your asymptote?
Correct. Correct. So vertical asymptote at x equals -2, 0 at x equals -8. Okay, so let's check our intervals. All right, we're checking into here. You don't have to go back to the beginning where it's more complex. All right, let's check out -10. Again, don't go crazy. What's happening? Ollie? Jackie, you got a question or go?
Why is -8? Like why is it a 0? Not why is it like a numerical value? Yeah, but why is -8?
Well, because that's what makes this fraction 0. A fraction numerator has to be 0 for the fraction to be a 0.
So we just found that x.
That's the same thing as a 0, yes. Yeah, it's just a different name for it. Yep, it's okay. Okay? When my son was 5, we played YMCA. I didn't play it. I was watching. Okay, basketball. He's 5. And you know how everybody's like, get the rebound, and they just it like 1,000 times, right? He gets in the car and he's like, what's a rebound?
Oh my gosh.
I mean,
Is he still 5?
no. 29. But my point is, you've got to understand the language here to get anywhere. Okay, so -10. What's above what's that going to make my numerator? Positive or negative? Positive. Because you put a negative of a -10, that's a positive 10. Positive 10 minus 8 is positive. And what about -10 plus 2?
Negative.
That's a negative. So if I have a fraction that looks like that, that's going to create a negative, right? Okay. Let's plug in -6. -6. The negative of -6 is 6. 6 minus 8 is
Negative.
and -6 plus 2 is also negative, so that makes positive. Okay, whatever that is. Okay, and then let's try 0. 0 minus 8 is 0 plus 2 is, and that makes, okay, so we are looking for greater than, okay? So that means we want positive, right? All right, so Alabama, what is that? Why did you include the -8 and not the -2? Okay, and -8 is a 0 or x intercept or root or whatever you want to call it. Okay, good job. I'm like, shoot, I'm tired.
Me too. No, I'm lost. It was in August 11th.
Okay. We have a little time. We're going to, I'm going to just, that's what we're doing right now. Yep. We're going to put some problems at you. Marcella. Please do. All right. Let's see. Let's find g of x e 2x cubed plus 5x squared. Ladies, there's your g of x. Okay. All right. List my potential rational zeros. Potential rational zeros. We are not using calculators. No. That's not gonna. No, potential. No, I didn't ask you to find them yet. Okay, well, you have to look it up then. Hence P over Q. There you go. That's your name. I know.
Wait, we don't like you. Can you tell me?
Why? Why?
It's okay. Orange is an ugly color. I don't like oranges.
All right, potential. This is chapter 4. We even went back to chapter 3 on this test. Remember, we will be going back to chapter 3. Use this quadratic. So. Just quadratic. I feel like you should be good. Yeah. All right. Okay. We know it's P's over Q's. How are we going to remember if P comes from here or P comes from here? How do we remember that? Because that is a problem. Okay. Well, I like it. All right. Okay. So P is at the end, as in period. We're going to talk about that other period, right? Okay, that's Q. So factors of P over factors of Q. Those are our potential. All right, so what are they? Plus and minus. Give me one, Josie. 15. Give me another one, Melissa. 15 over 2. Give me another one, Julia. Or another 2, rather. Plus or minus. Oh, we're putting them together already. Okay, so 5. All right, Michaela. 3 over 2. Okay, we're doing it kind of willy-nilly. You need to have some kind of process. You got another one, Miss Jackie? 3. Okay. Another one, Deidre? We got 15. 1. We missing any? 5 halves and 1 half. Okay. So my suggestion, list all your factors. 15, 5, 3, and 1. Okay. And then 2 and 1, and then have some kind of process, because if you do it, and I know I asked you, if I had just stuck with Josie, she probably would have had a system, but when I grabbed you, you were doing willy-nilly. If you do it willy-nilly, you're going to miss something. Okay? So those are the potential. All right, so I'm going to plug it in, don't you, because this is non-calculator. And I'm going to give you one root. where one intersect. That's all he likes to call it. You're welcome. You got it. 30, no. P over Q. 30 is not a factor of 15, it's a multiple. All right, one of the zeros is -5. Find how many possible ones should I have? 3. Okay, so I'm giving you 1. Find the other 2. -5. Now I'm not telling you they're all. Could they be imaginary?
Oh,
The other two?
No, wait.
Could be. Because it'd be a quadratic, so they could.
No, but like, why would they do that?
Well, because it's just
Why?
Precal. Uh-huh.
Alright, thank you.
You're welcome. Okay, calm down.
No, that's not it. It's equal to 300. What? -5.
Yeah. Put in a -5 and you're going to stick that division box. All right, let's I gave you the factor. Zero. Yes.
Because it should work out for me.
Yes, it should be 0. Yeah. Okay, did we find some nice, pretty roots here? Okay. Now, if you're still plugging in, you're not being very efficient because you know this is a cube. So that means this is a what? A quadratic. And there are better ways to find zeros from quadratics, even without your calculator. Then let's try one of these 15 roots here. Yeah, if you test them all on the test, you're going to be crying because you don't have time to finish the test. Yes.
No, it's just something I want.
Right. Okay.
I have to lifeguard one more time, or 2 more times this week.
Right. Okay, say that again. This was A0 was your penny in your cube. Okay, so what do we have? 2 and 5, 15? Would it be -2/15? This is 8. Oh, you're right. Okay. Yes. Uh-huh. Right, -1 to the third is negative. No, that's not what that says. That says -1 to the third power, which is -1. Oh, so you already you took, got it. Okay, sorry. And then, I'm still not following you. So I got you to here now. I'm really not following you, but I'm a little dense. There must be some background that I'm missing. Okay. I'll have to look into it. It looks like, it looks familiar, but I'm not following it. Person to me? Check it out. What's up, Molly?
I was just finishing the problem there.
Okay.
Making sure that it's all good.
All right. Let's see. So, oops. We need to